welcome to another episode of Xa Talk Show. We are going to code Wolfram language today. We are going to code Wolfram language 3D graphics lighting system. So it's fantastic. You can have different light sources. You can have multiple light sources. Each one can have different color, and you have different types of light source. You have ambient light, which is like a room, well-lit room. You can have direction light, which is like sunlight. You can also have spotlight, which is like a flashlight. Outside of it is dark. Or you can have a point light, which is like a lamp. It radiates lights in all directions. So you can have different light sources, multiple light sources, different light color, and different types of light. So the Wolfram language 3D graphics lighting system is fantastic, flexible, and powerful. But also the Wolfram language, the material, the surface, let's go to Wolfram language. So I've been working on, can you see it? Yeah, you can see my screen. If you are watching offline, play at 1.5 speed or higher. If you are watching here, say hi, okay? I'm doing well, thank you, Palash. So I've been working on the Wolfram language graphics systems, okay? So there are kind of two parts. One is the Wolfram language, plot and visualization. So you can see, can you see it? Yes. So you can see there are like literally few hundred functions to do plot. So you can have a simple plot of a function, or you can have pie chart, and so you have hundreds of them. And then you can have plot 3D. Let me just show you some of it. So you can, so this is a function, plot of a function. Then you can have plot points and perspective, for example this one. So let's copy the code. Let's show that. Okay, so start Wolfram language. So play at 1.5 speed or more, and ask me questions if you have any questions. Starting Wolfram language. Okay, Wolfram language, if you don't know, it's the most advanced programming language by far, like by a magnitude, more high level than Haskell, Lisp, Clojure, Rust, OCaml, F# or C++ by a magnitude. You can do machine learning. It's all built in. Like by default, you have 7,000 functions. So let's code. Let me show you. Okay. Wait, not Control Shift Enter to evaluate it. So let's make it larger, 150, and let's make the window larger. So okay. So there you go. So so you can see we got lots of cubes on a lattice. Fantastic, you see. And here is perspective. This illustrate perspectivity. You see, fantastic and beautiful. And when you view this bunch of cubes, a grid of cubes, you have this phenomenon. You can kind of see, they became a hexagonal star shape when you view it in different angles. So it's amazing. How many lines of code? One, basically. 2 lines of code to do this. Okay. In other languages, you're gonna need 50 lines or more. If you view them now, if you don't know, so normally our viewing system is called projection, point projection. So projection from a point. So that's our visual system. But you have what's called orthogonal projection, which is kind of like if you are viewing things from infinitely far away, like very, very, infinitely far away, then you got this what's called orthogonal projection. So you see, they look very different. So you see, that's their effect. You see, you can rotate it, a bunch of cubes. You can rotate it to such a way you see like that, But if you view the normal, projection, point projection, you never get to see of all of them like, like 2D squares, you see? So that's a demonstration of perspectivity, okay? One is perspective projection, the other one is orthographic projection. So, but that's not what we're gonna do today. I'm just showing you some of the, features of Wolfram language. You got plus style, color function. So let's see. We're gonna show lighting, okay? So we're gonna do some lighting. Okay, so let me just do it. Hello, Tamid. Okay, so let's just code it. And oh yeah, so if you don't know, and Wolfram language, you can download it for free. Okay, since like 7 years ago, download it for free. And you want to also download the Jupyter so that you can have 3D graphics in Jupyter Notebook. Okay, or just pay for the Wolfram language. Then you get the Wolfram language notebook. So everything is integrated. You don't have to go to GitHub this one and configure it, it's just one single thing. Okay, so download it for free, and you can get my Wolfram language Emacs Wolfram mode. So you can code Wolfram language in Emacs. That's what I do. Okay, so today we want to build a lighting system. So let's just code it, okay? So show in browser. So that's, let me just code it. Let's start a Wolfram language code, okay? So we begin objects, okay? So X objects. Okay, we define a bunch of objects, brackets. So we want a torus, okay? Torus, inner radius, outer radius. The center of the torus is 0, 0, 0, okay? And then you need two radius. I believe that's, so center radius 1, outer radius. So let's look up the documentation. Turn on JavaScript. Okay, and magnify. So good. Comment, okay, comment. So torus, you got inner and outer radius. So let me just show this, okay? So you got a torus. Then if you want to show it, so you just say graph 3D, graphics 3D parenthesis. You put the graphics primitive inside, then you add options. So I want axis true, okay? So copy that. You can type it in Wolfram notebook, of course, directly. So paste it, run it. So there you got the torus, okay? So you see, as I rotate it, there's one feature. Let me show you. If I rotate it, you can see it kind of jumble around. So you see, if I stop there, it like all of a sudden shrink because it wants to fit this 2D display. But if I make it, I rotate it, then it becomes not large again. If I rotate it, that good. So I don't want that. I don't want this jump. So what you do is add another option. Control L to copy the previous input. Then you want add another option, spherical region, okay? Spherical region true. Now shift enter to evaluate it. So now you see when I rotate it, it doesn't jump. So torus is a graphics primitive. You got tens of it. You got torus, sphere, and all others, or you can have a mesh or whatever. Then you use graphics 3D wrapper to basically this makes the torus show as a graphics. Then you can add options, axis true, and so on. Okay, now let's add color. Okay, so copy that, copy back to Emacs. So we kind of have that spherical region true. Okay, so let's delete that. Okay, so that's a graphics, and so this is a graphics object. Now, is the torus the way we want it? Yeah, that's fine. And no, we want it to the torus. Let's change the position. So x equals to -2. Okay, let's say that. So we got a torus, and let's have another sub-object, sphere, okay? Sphere, that's right, and by default radius 1, right? So sphere, yeah, so that, okay? So copy that, and okay, so let's, we copy that, paste it, paste it, evaluate, missing a comma, paste it, evaluate it. What did we miss? Okay, so the graphics 3D takes 2 arguments. So if you have more than one graphics primitive, you need to put them inside the list like that, okay? And you need a comma there, okay? So back here, select, paste. Why do I have extra comma? Yeah, remove that, okay? Select, paste. Why are they red? I don't understand. Evaluate it. Wait, something is wrong. Graphics 3D. Oh, missing a comma here. Comma, okay? Evaluate. Now, fantastic. We got this. Funny. Okay, we'll leave it. So yeah, comma, okay? So now we got 2 objects. Let's add another object. Let's see, cylinder. Okay, so by default, so where do you want the cylinder? So how do you specify the cylinder? Cylinder, okay, so it takes two points. That's the end and the other end, okay? So let's say cylinder, where do you want it? Let's see what is, so 0. Okay, cylinder, I want it on the right side. So cylinder takes 2 arguments, 2 points. The first one is x is 2, y is 0, z is 0. The second one is same thing, but z is 3. Okay, so let's show it. Paste, run it. Okay, something wrong again. Did we miss a comma somewhere again? Wait, cylinder. Oh, you're missing a radius. That's right. Wait, radius is optional. So why do I have a problem? Let's see. Sphere, torus. Do you need to? Oh yeah, you need to bracket them together. So bracket them together. Okay. Radius. Let's just be explicit 1. Sphere. Let's add also coordinate for the sphere. Let's be explicit, and radius 1. Okay. Copy that. Okay. Select, paste, run it. Fantastic and beautiful. So you can see now we are using the default lighting system. Okay, now let's add some lighting system. So but now we got the objects. Am I doing good, guys? Comment how to so how many people? 2. Okay, wow, fantastic. 2 people watching. Okay, so now we got a bunch of objects. Let's save the objects as object here. Okay, so this is the object. You can evaluate it, so we don't have to type it every time. So that's the object. Okay, so the object is that. Then you just say, so x objects. Okay, and now lighting. Okay, now the thing we want to do. Not lighter. Lighting. Okay, now let me get my coffee and tea. So there is my tea, fantastic. And now this is fruit juice, melons and a bunch of, let's see, can you see it? Melons and grape juice and bunch of juice. Wife made, fantastic. Oh, you have to shake it. Okay, let's switch to, you see, the beautiful graphics we are doing. Okay, now let's add lighting system. So I've been studying the entire lighting and stuff. There's a lot because it's like a it's like a CAD system. You have all sort of lighting specification and ambient light and so on. So let's go to my programming blog. So you got the whole system of graphics. So lighting, let's go there. So you got, let me just introduce you. So lighting interacts with surface color. So first of all, you can have surface color. Surface color, you can specify any color or any color and any color model. You can use hue, you can use RGB system, you can use named color and so on. But then you got glow, so it's like a light. You can make it glow. That's a surface property. And then you can specify specularity, that is, make it shiny like a metal. And then you can have material shading. That's more complicated. You can like specify material shading. Okay, so material shading, and then you can have, let me show you, okay, color function, which is where is it? Okay, so color function, so that lets you change the color of a surface or whatever by a parameter. So for example, typical like that. Okay, then you can have, so anyway, so on a surface you can have like maybe it's shiny, or you can have transparency. Okay, where's transparency here? You can have transparency, you can have shininess property, you can have different colors. Okay, that's one thing. Then you can specify lighting. Okay, then the lighting interacts with the color of the surface at particular places. Okay, so where's my lighting page? Okay, so let's go, not there. Yeah, lighting. So let's go there, open it. So lighting can have different color, can have multiple light sources, can be different type. You can have directional light like sunlight. You can have spotlight like a flashlight, where outside of that spotlight cone is totally dark. Okay, spotlight. Or you can have point light like a lamp. So imagine a lamp in a forest. there's no light, so so different, it casts shadows all around it. Then you can have ambient light. Ambient light is like in a room, like basically no shadows, there's light all around. So you can have all these different light sources. Okay, so let's try to specify one. Okay, so we want directional light, point light, and spotlight. Okay, so okay, let me just copy. Let's just copy code. Okay, so this is close. Yeah, so the lighting we're gonna try ambient light, directional light, copy, and let me just show you. Okay, so we can keep this interesting. So you can see, wait, this is no, this, so in this case, you can see in this case the light is attached, is fixed to a position relative to the graphics. So as you rotate it, it doesn't change. It just fixed to, this is a directional light, like sunlight. So you can see, so the light is like, 111, it's on the upper corner. But I want the light to be like in front of the screen, so that as I rotate it, I can see the light will cast different shadows. Okay, let's try that. So directional light, so you wanna check the documentation, and here it is, and you want to let's magnify. Okay, so I want it to be I want the light source fixed with respect to the screen. So it's like, so you see the 3D modeling is fairly complex. When you say you want the light source fixed to the screen, it's kind of, it's kind of detached from the 3D modeling at all. So it's like it's outside of the modeling. It's kind of a meta modeling. So yeah, so image scaled, image scaled. That's what I want. Image scaled. Okay, so that's what I need to use. So let's copy that, paste, and the light source will be, let's see, image scaled. Okay, I think I know what to do. Directional light. Okay, so normally, so it takes 1 point. Yeah, okay. So we can just image scaled. Okay, I believe that's it. Click, paste, do it. Okay, now let's rotate. Wait, that's not happening. Oh yeah, so I kind of know why. You see, that's the reason is because we are using parametric plot. When you use parametric plot, it kind of just fixed it. Okay, so let me try to get it to work. Okay, I cannot be sure it will work, but so we want to display that, and lighting will be that. Okay, so that is the option, and the x is the graphics, okay? And the color, we're gonna make the color just totally white, okay? So try it. Yeah, okay, that's good. Now you can rotate it. Okay, so I want the spherical region, okay? So that when we rotate it, it doesn't jiggle. So color white spherical region true. Copy that. Okay, back to here. Paste, run it. Okay, now you see, now it's by default the light is fixed to the screen, so you can see that's good. But also by default they have more than one light. By default they have like 4 lights, one ambient light and the other 3 are a direction. They are like directional light or something. Anyway, so we want to go hardcore. We want to specify everything ourselves, so let's not rely on the default. So let's do that. So lighting, okay, and spherical region. Okay, so yeah, let's try it. Run it. Okay, you got error. Why is that? Graphics 3D box is not oh yeah, I forgot, you need to extract. So you can first, okay, add, that means take the first part of that XX. Okay, now let's see. Fantastic. You see, now there's only one lighting there. Okay, there's only one lighting. Let's make it red. Okay, now we have a red light, directional light from one direction. Okay, it didn't work. Why is that? I don't know. So, you know, it's supposed to be red light. I do not know why it works, why it does not work. Okay, so that's the reason, you know, these complexities. I've been working on this in the past week. So, you know, to figure out, there are so many issues. I think the reason, you see, we said we want a red light, but it's not working here. I think the reason is because we are using parametric plot. Okay, so but let's go back to our using graphics directly. Okay, so let's like here. So let's okay. So now let's ambient light. Okay, so there's lighting, ambient light, and lighting. Lighting, directional light, and okay, so that's all the possible options. And ambient light, let's get the rest. Lighting, point light. Okay, so point light, and what's the other one? And lighting, spotlight. Copy. Spotlight is like a flashlight. Okay, so we got these options. Now we can do this. So first of all, image scaled. Yeah, we want that. We don't want that. So let's say that. Yeah, so let's say that. Okay, copy that and paste, run it. Okay, so now, so you can see the lighting is kind of on the right side, right upper corner. Okay, so you can kind of see. Let's see, if we rotate it, you can see the light, you know, look at the sphere in the middle. So you can kind of see the light is always on the upper upper right hand side of my screen. So now let's change it to red. Now red light, now it works, you see. Okay, that's directional light. Okay, so that is directional light. Okay, now we can change it to ambient light. Ambient light is the kind of the most boring one, because ambient light basically no shadows, it just everything just glow. You see, that's ambient light. You know, ambient light, boring. Okay, so next, spotlight. Okay, wait, point light. So when you want a point light, where do you want it? Let's say, so point light, let's see, where are our objects? So point light, we don't want directly at top. We want, let's see, sphere. Okay, so let's see, okay, 0, 0, 0, and 3, okay, like right in the middle, above. Okay, so now let's try it, paste, show it. Point light, there it is. So this point light is like a, you know, light from a point, like a lamp. So right now the light source is right above the sphere. So, and it's fixed. So you see, fantastic. You see, bottom is yet or shadow. Fantastic. Okay, last one. So we got point light, and then we got spotlight. Okay, so let's do the spotlight. Copy, paste. Let's say spotlight green. Okay. So spotlight from 0,0,003 and at the degree of pi over 3. So in other words, that's let's say 60 degree. Okay, you can do that. Okay, so now paste it, run it. So it's from top above, 3 units above, and 60 degrees. You see? Can you see? Fantastic. Okay, I think that's it. That's what we're gonna, that's, you know, that's what I wanted to demonstrate. So, you know, I'm writing a tutorial. Right now it's like incomplete. You know, so you can see right now you don't have graphics. So I'm writing a tutorial. And also, you know, why is that when we use on the parametric plot, it does not seem to work? I think the reason is because there are some lighting properties attached to the graphics objects already. So when you do a light, when you add a light, it doesn't work. So anyway, that's what I want to demonstrate, I think. So any questions? Thank you for the demonstration. Thank you for watching. Is everyone good? Happy? 6 people. Okay. You know, donate to me if you enjoyed my stuff. If you work at Google, or if you are a professional programmer, go to xahlee.info. xahlee.info, lots of stuff. xahlee.info at the bottom. PayPal, Patreon me, Amazon gift card me. Okay. I want to buy a shoe, $30, like a flat shoe and stuff. Anyway, donate. Okay. So that's it. Any questions? Otherwise, we shut down in 2 minutes. Yeah. So today is short. Short is good. Then we're gonna do another tomorrow. Tomorrow is maybe Emacs or maybe some other thing. Okay, so the code here, we're gonna copy it. So those are successful code. These are experimental code. Delete it. So these are successful code. Put it back syntax correct, show in browser. So that is what we've done. And I'm gonna upload this so for people who came in and watch later, they can, use the code. Okay, that's it. Bye, guys.